So my name is Laura Brown. I'm a senior lecturer here at IU in the chemistry department, and I teach all things organic chemistry. So one of the classes that I teach is a class that's required for the chemistry and biochemistry major. So most of the students in it are chemistry and biochemistry majors, and some elect to take it. But I've been informally surveying that class over the last few years about the student participation in research. From that informal survey, we saw that about 60% of those students are not involved in any research whatsoever. Of the 40% that are, half are in a different department. So in our department, we're providing research experiences for about 20% of our majors. So then I started thinking, who are we missing and why, and what can we do about it? So first of all, it's not feasible for all of our majors to have the traditional research experience where they work closely with a faculty member or their graduate student in their lab. At any given moment, we have about 400 chemistry majors, so it's about 100 per class, give or take. We don't have that many labs. So that's not feasible. But I did start wondering about who's doing research and who's not. It seems like the students who aren't doing research generally fall into a couple of categories. So one is, the students who just don't know about it and don't know how to do it, right? So it's a really informal process. You have to approach a faculty member, so that means you have to have some idea about what you want to do. And you have to know to approach them, and you have to kind of come into college knowing that that's something that's expected. So we're definitely missing our first generation students. And another major group that we're missing are the ones who, are working 40 hours a week and can't put the extra time into a research experience. I started thinking about what to do about it, and I had an idea of incorporating a research experience into a class. Now, I'm not the first person to come up with this idea. It has a name, course-based undergraduate research experience. So to provide a research opportunity for students to just sign up for. So they get course credit towards their major. They don't have to spend any extra time doing it, and they get a meaningful research experience. So there have been a lot of studies about these types of research experiences, and you get the same kinds of gains from the CURE research experience as you do from a traditional research experience. So I was happy to hear that, to know that this would be actually beneficial in the way that I'd hoped it would be. The hardest thing about developing a CURE is to identify an appropriate project. So the research project has to be something that the students can contribute to within the confines of a class. So the lab courses usually meet once a week for 4 or 5 hours in the lab. And that's not how research is done, right? It's every day. You often run reactions overnight. And you also have to design a research project that a lot of inexperienced students can contribute to. A lot of the work that was done over the summer that was supported by this instructional development grant was to work out the chemistry to make compounds in 4 hours once a week, right? So I had my students, set up a reaction, and then I would tell them, well, don't touch it for a week. And that's really unusual. So for organic chemistry, you're normally following the reaction constantly, seeing if it's done, seeing how the reaction is progressing, and then you work it up or you stop it as soon as it's over. But I wanted to make sure that these were going to be robust, that there's going to be no degradation over the week. So I had them just leave it alone. And we worked out procedures such that it would work in this class. And it did. So the students were able to make a small library of different compounds. And remarkably, we got one compound that had some dose-based activity. So it was real. And we've repeated that since. So we're going to continue the project. A different faculty member ran the lab this semester and did the same project but with different compounds. And we're going to make some meaningful changes to the compounds now that we have some idea of what's important for activity. One of the benefits of undergraduate research is that students tend to stay in their STEM degree, so retention in STEM. And one of the mechanisms of that, it's thought that you increase their identification as a scientist, or their tendency to identify as a scientist. And that's the outcome that I was sort of looking for. So I used a readily available assessment tool called the CURE survey that was developed by some professors at Grinnell. And basically I filled out some information about the class, and then the students took a pre-course survey and a post-course survey, and then I got the output. So, so from that, I was really interested to see is that in the pre-course survey, only 4 of the, I think, 19 students that filled it out said that they plan to pursue some, grad school in science, right? So any part of science, master's or PhD. At the post-course survey, it was 7 out of 15 that said they wanted to do that. To me, that's pretty good evidence that they identify as a scientist more at the end of the class than they did at the beginning. And other things that I looked for were, some skills that I'd hoped that they would develop, like reading the primary literature and that kind of stuff. And certainly they showed them, or they reported improvements and all of that. So these are all, self-reporting, but still useful to me. So we plan to continue using this assay, but making more directed changes to the structure in this class. Now, ideally, I'd like to come up with a project that I can use in the big, 200-person organic chemistry lab. That's just a whole different, size of problem that will take a lot of thought.